So, quick sorption example problem. A sealed 1 liter reactor contains 700 milliliters of water and 300 milliliters of soil. Soil has 2.2% organic carbon and a density of 2.1 kilograms per liter. Temperature of the reactor is 25 degrees C. After adding 250 micrograms TCE to the reactor is incubated until equilibrium is achieved between the two phases. TCE has a log KOC of 2.28, assuming KOC has units of liters per kilogram. Assume no biological or chemical degradation of TCE occurs during the incubation, and since it's sealed, no TCE exits or enters the reactor after it is initially added. What's the aqueous phase concentration of TCE at equilibrium? Okay, so we have our reactor. We have here sitting on the bottom of the reactor 300 milliliters of soil, and up here we have 700 milliliters of water. Okay, and we've got TCE floating around in the water. Some is going to sorb to the soil. Okay, and so we start writing out what we know. We know that the log KOC is 2.28, and so the KOC is 10 to the 2.28, which is equal to 190.5. And we can write out definition of KOC. 190.5 equals TCE that's sorbed onto the solid phase divided by TCE aqueous times the fraction of organic carbon. Okay, and so this guy is 0.022 because it's 2.2% organic carbon. And so I'm just going to go ahead and write TCE solid in terms of the rest of it. So I get 190.5 times TCE aqueous times 0.022. Now the other equation I have is a mass balance equation. I know how much mass I have of TCE in the reactor. It's 250 micrograms, and nothing's entering or leaving or being degraded. So I've got 250 micrograms. This has to equal the aqueous concentration times the volume in the aqueous phase, right? Concentration is, let's say it's a mass per volume. I multiply by volume and I get the mass of TCE in the aqueous phase. So this is 0.7 liters plus the concentration of TCE in the solid phase times the volume of that phase, which is 0.3 liters. And then since this is a solid, the concentration is going to be in a mass per mass units. We can verify to ourselves that that's the case by saying this KOC has units of liter per kilogram. That's said in the problem statement. So when we look at KOC and its definition here, we can see that the top would be in, say, micrograms per kilogram, and the bottom would be in micrograms per liter. And when we divide micrograms per kilogram by micrograms per liter, we get liters per kilogram. Okay, so we've got a mass per mass concentration in the solid phase. And so when we have mass per mass down here now, and we're multiplying by a volume, we need to multiply by the density, which was 2.1 kilogram per liter, in order to get these units to cancel. Okay, so this is our mass balance equation now. Now I'm going to plug in this guy here that I defined into there, and I will get 250 micrograms equals TCE aqueous times 0.7 liters plus 190.5 times TCE aqueous times 0.022 times 0.3 times 2.1. If I reduce all of this down, I get one term with TCE aqueous here, one term with TCE aqueous here. I end up with 250 micrograms equals 3.34 TCE aqueous, and therefore TCE aqueous equals 74.8 micrograms per liter.